please.
So at this step, we have all the coupling files. So do we have any session or any
Yes.
introduction how to
Yes.
extend?
Absolutely. So let me repeat. I was telling it at the beginning. We have total 3 sessions of knowledge transfer. First on couplings, second on rates, and third on observables like charge transfer rates, photoluminescence, and such. So session 1 is today. Next week there will be practice talk for Doctor of Defense by Aaron, and in 2 weeks we will continue this knowledge transfer sessions.
Okay.
So we need to prepare patients to survive these 3 sessions because they have no sense without each other. They are like one big core of materials that needs to be overviewed together.
Thank you.
Okay, Ewan, floor is yours.
Yep. So you guys can see my screen, right? Okay. I guess almost everything is covered by Jabed and Amir. So I guess there is just a little modification for spin polarized calculations. I guess the P files are the same. Input overlap is also the same. But I guess here I have a comment. So basically, typically we just use HOMO minus 40 to LUMO plus 40. So that is in total 82 orbitals. This is more than enough for the future coupling calculations. And for the in-car, I guess we just need to add a tag, iSpin equal to. And just remember we are doing single point calculations. So SW equal to 0. So the Corey.sh file is also the same. So the main difference is we use a special B script file. This is my modification. So here is what it looks like. So I guess the main difference is we have 2 new subfolders. One is up, one is down, which corresponding to spin up calculations and spin down calculations. So in these 2 folders, the coupling files will be transferred to these new folders. Okay, so if everything is successful, we can find these files like coupling files, oscillator strength files, and energy path files. And we should remember up and down are different. So they have very different data. And finally, this is what coupling looks like. I guess Amir and Jabed has already talked about it. So basically, the coupling is just a n by n square matrix. So the diagonal elements are 0. I guess that's it. Any questions?
Many thanks, Ewan. Please join me thanking Ewan for this really quick and intense presentation. I never thought it is possible to present in so condensed form, but every practical steps were included there. So any questions are welcome.
I have a question.
Please.
Maybe not related just to this or even for no spin calculation. So it seems that codes are written to just consider 1000 steps. So if we change the time step, it's just a general question. We need just enough number of steps or enough time range. Actually, for instance, 1000 picosecond, femtosecond, or 500 femtosecond, or no? Just we need 1000 step. Doesn't matter what is the time step. For instance, if we decrease time step to 0.5, we should go 2000 steps to have the Concar files, or no?
I guess in the end, we do the average, right? So I guess for average purpose, the more the better, right? But typically 1000 steps is enough,
For
at
each
least
time.
for our calculations.
So let me contribute to the discussion. In the session 2, we will convert this multiple coupling files into single file with rates, averaging procedure. And suppose we have a long data set of the same nature and we average something. And we use so many elements included into the average. So as far as we increase number of elements to generate the average value, the result getting more and more precise. If we do not have enough elements, the result will fluctuate. Will go a little higher, a little lower, but with large enough number of elements, it will converge to a certain value. And empirically, 1000 for the systems that we are considering is sufficient. Sometimes the convergence is achieved even with 100 steps. So making a 1000 step is a over cautious approach. And this is so a comment for Jabot. This is the main difference between surface hopping and Redfield. So if one practices surface hopping, then one needs as many time steps as long time interval one wants to cover in the dynamics and electronic dynamics. And here the shorter ab initio dynamics trajectory will allow longer electronic trajectory. Yeah, thank you. More questions to Yun? I have one. So, in which circumstances the procedure provided by Amir and Jabot is not sufficient, and one needs to this spin polarized couplings? Like if we have an arbitrary system, we have its property, how do we judge if we need to do this additional calculations for spin polarized couplings?
I guess for systems dealing with transition metals, I guess spin polarized calculation is needed.
Okay. Please raise hands in the Zoom reactions, those who are dealing with transition metals. Okay, Lola. I think Sarah should raise hand as well. Steven answered yes. David, do you deal with transition metals? Is lead transition metal or not?
No, lead's not transition metal.
Okay. Yeah. Okay. At least third of attendees deal with transition metals. And would you please give the another circumstances when spin polarized calculations are needed? If there are some additional.
I guess also if your system has different numbers of alpha and beta electrons, like they are in high spin configurations, then you need to consider the spin polarized calculations.
So any system with unpaired electrons?
Yes.
And what about radicals?
Yes.
Okay, so if we are doing chemistry with radicals, it's also basically they typically have unpaired electrons. Yeah. Thank you. There is a question in the chat line from Mid. So he is asking, regarding the column probabilities, they do not add up to 100%. Does this mean low transitions occur?
What mean by does not add up to 100%?
Sorry, I meant to say one, but like my understanding is these values are just the probability of electrons moving to that orbital, and then we're just saying that. My understanding, if we have a probability, it could add up to 1. So, are all of these probabilities supposed to add up to a total of 1, or is it just each column supposed to add up to 1?
Yvonne, do you have a comment in the response?
I'm not sure I understand this question, but I guess the larger the number, the higher the probability for the transition.
Yeah, my belief is, so I guess when I think of probability, the max between all probabilities, you'd add it up and they should equal 1, the summation of them all. So like, does this summing all of these values?
No. So let me bring in the reference point. So suppose one of us heated system to 0 degrees Kelvin, means heated, no heat, no momentum for each ion. Then run molecular dynamics at 0 Kelvin, and then plug in all outcome of such molecular dynamics into this procedure. What will be the probabilities of transitions between orbitals?
My initial thought would be 0.
Yes, all probabilities will be 0, and they will never sum up to the 1. So there is no reason for all probabilities added together to be normalized to a certain value. There is a completely normal situation when electron is sitting on the orbital for a very long time and has small probability to recombine somewhere else.
So we would look at it as like independent. I guess,
yes.
I don't know, there's a word to it, but
they're independent. And what you are asking, maybe you were reading some substantial and deep theory books. So there is a so-called Thomas Reiche-Kuhn sum rule for oscillator strengths. So in theory, the probability of optically induced transitions, oscillator strengths, must be normalized to the number of electrons. But this is only a theoretical concept, and it applies only to the oscillator strengths. For non-adiabatic couplings, there are no such theorems, and there is no reason to expect such normalization.
Okay. And then if it's a negative value, so is that suggesting that electrons would be leaving that orbital?
No.
No?
So and I appreciate very much this question. Would you like to answer it? This is a very good provocative question, and I'm thank you, Mead, for asking it.
In my opinion, the negative value just means in different directions. Like the positive is from orbital I to orbital J, right? The negative just means from orbital J to orbital.
Okay. So the values of coupling are overlaps of orbitals, of quantum orbitals. Orbitals generally are complex, and they may have positive and negative values. And in order to get probability, one needs to take this overlap squared, which will be always positive. So what we compute, what is in the coupling, it is probability of amplitude. It is a, so to say, square root of amplitude. And just by the nature of these calculations, it can be negative or positive or even complex. But the procedure of that Jabot has introduced, adding together several terms that rotate clockwise and counterclockwise, will cancel the complex part of this overlap. But real part can be positive and negative, and to speak about probability, one needs to take the value of couplings absolute value squared.
Okay.